Hi guys, we are going to finish the spring break packet. My full intention was to do 3 videos at the beginning of the spring break, and I did the first video, and then the whole week got away from me. A lot of crazy stuff happened. Everybody's good. I hope you guys are having an amazing week, and please forgive me for taking so long to get this last video up. So let's take a look starting at number 11. The total cost of 8 binders is $24. The price of each binder is the same. Which equation represents the proportional relationship between the total cost T and the number of binders N? So we're looking at a problem where we have to deal with proportional relationships, and we're also looking at a problem where the math is not difficult, and you could probably all answer the question if it said the total cost of 8 binders is $24, the price of each binder is the same, how much was each binder? You guys could probably figure that out in your heads, but that's not what we're being asked. So let's go back and read again. The total cost of 8 binders, okay, and it's important to me that that's the total cost, is $24. The price of each binder is the same, okay? Which equation represents the proportional relationship between the total cost T and the number of binders N? Okay, so we have the total cost. We know that T is equal to 24, and we know that N, the number of binders, is equal to 8. Okay, and so I'm going to go over here, my key information box. I have $24 for 8 binders. All right, and I know that in order to figure out how many, how much each binder was, I would do 24 divided by 8, and that's going to give me 3. So essentially, I need to find the equation here that tells me that relationship, that same relationship that I just figured out right here, only using T for that 24, the total cost, and N for the 8, the number of binders. Okay, so the first one says T is equal to N divided by 3. And so if I were to plug that in, it would be 24 is equal to total cost, right? The number 24 is equal to N, which is 8, right? The number of binders, total cost of 8 binders, divided by 3. Okay, so I know that 24 does not equal N divided by 3. Let's try this here. T, all right, so 24 is equal to 192. I'm crossing this out. 192. Let me erase this. Give it is equal to 192 divided by 8. I know that's not true. Okay, I can cross out B. T, which is 24, is equal to 3 times 8. And this I'm liking a little better because that's true. 3 times 8 is 24. And then just for the sake of looking at D, it would be 24 is equal to 8 plus 16. Okay, that's true. However, it does not give me, that's not a way that I would write a proportional relationship. So my answer here is C. Okay, so my T, my total number, is equal to 3 times 8. And so let's just say, why would T and N continue to be okay? All right, so T is for your total cost, and your N is for your number of binders. Okay, and so here I said, all right, well, if my total cost was $24, I have 8 binders, right, at $3 each. If I were to say my total cost here was $3, that would be 1. Okay, if I were to say, let's plug in any other number, right, if I were to buy 4 binders. Okay, that would be 4 times 3, that would be 12. Okay, and I know I have a proportional relationship. Now, again, I'm going to show you this cross multiplying trick. This may not be something that you know, but if I can cross multiply all of these, I know that I have a proportional relationship. So, for example, 3 times 8 is 24, and 1 times 24 is 24. And then I can go down here and say 12 times 1 is 12, and 4 times 3 is 12. Okay. And if I put in another one, if I said, okay, let's see what would happen if I bought 10 binders. Okay. So 10 binders would cost me at $3, it's $30, right? So let's see, 30 times 4 would be 120, and 10 times 12 would also be 120. Okay, so that's one of the many ways you can tell if you have a proportional relationship. Bottom line, my answer here is going to be C. All right, number 12. The perimeter of a rectangular field is 168 feet. The field is 36 feet wide. How long is the field? Okay, I have the perimeter, that's important, of a rectangular field, that's important, is 168 feet. Okay, and I know that the field is 36 feet wide, so how long is the field? How long is the field? Okay, so I'm going to draw my field. All right. We're going to pretend that's a really beautiful rectangle here. All right, and so it is 36 feet wide. And for the sake of this, I'll go ahead and put 36 here, 36 here, okay? And I know that my perimeter all the way around is equal to 168. Okay, so this is kind of my key information box, this is my little drawing. Okay, so I also know that perimeter is equal to 2 times the length plus 2 times the width. So I'm going to go ahead and plug in the information I know. Here I have 168 is equal to 2 times the length plus 2 times 36. Okay, I'll pull this down here. It'll be 72. Right, 36 times 2 is 72. Okay, and then I have 168 is equal to 2L plus 72. I'll subtract 72 from both sides. Okie. So I did 168 minus 72, and that got me 96. So I'm left with 96. Oh, where's my pen? Where's my pen? Is equal to 2L. I'm going to move this, actually. I'm going to move this up a little. All right. Let's do it up here so we have a little space. Okay, so I have 168 is equal to 2L plus 2 times 36. All right, so then I'm left with 168 is equal to 2L plus 72. I subtract 72 from both sides, minus 72, and I am left with 96. So I'm left with 2L is equal to 96. Now, if we see here, this answer, D, this is somebody hoping that we are not going to remember to divide both sides by 2. Okay, so I have 96 divided by 2, and that is going to give me 48. So my answer here is going to be 48. L is equal to 48. Okay, now I can test this. I can say, I know that perimeter means all of these would add up, and I know that they should all add up to 168. Okay, so I'm going to really quickly with my calculator just test to make sure I'm right. Great, so I add them all together and I got 168. Okay, so I feel good about my answer because I've tested it in more than one way. Okay, so let's take a look at the story of our local news station here. Local news station is conducting a survey to determine the favorite summer movie of teens in the city. Okay, so I have a survey here. Favorite summer movie of teens in the city. How would the survey most likely get a random sample that is representative of the population. Okay. I'm going to read this again because these can be deceptive. So a local news station, so it's a local news station. All right, I want to think about that. They're conducting a survey to determine the favorite summer movie of teens in the city. How would the survey most likely get a random sample that is representative of the population being teens in the city? Okay. So, first one, by asking every fifth person at a local movie theater to name his or her favorite movie. What I'm missing here is teen. Okay. So, this is one of those specific surveys where we're looking for a specific population. So, I don't want to talk to every fifth person because I don't want to talk to an 80-year-old about his or her favorite movie because it's going to be different than the teens. Okay. B, by asking random teens from local schools to name their favorite movie. I think this could be it. Let's come back to it because I have teens and I have this local school. All right. And I have the randomness in it. C, by asking all the teens attending a current movie to name their favorite movie. I'm not going to totally rule this out yet. And then D, well, let's go to D, by calling teens from all over the country. So the problem with all around the country is that we're looking for in the city. We're looking for local folks, okay? Local news in the city, all right? So here I am, I'm back to B and I'm back to C. And I'm going, well, if I'm asking at C by asking all the teens attending a current movie to name their favorite movie, that might be representative. The problem is if they're all attending a current movie, it's likely that they're all going to name somewhat similar movies because you tend to go see the kind of movies that you like. So, for example, if the current movie is a superhero movie and we go, hey guys, what's your favorite movie? You're more likely to get a bunch of teenagers saying, oh, it's this superhero movie, than if I were to just ask random teens from local schools that had all different interests. So, for this reason, it is B. I wish it had said city schools and not local schools. I don't love the wording, but B would be the most correct answer here. And let's take a look at number 14. Which situation can be modeled by the fraction, and this is so tiny, 17 over 7. And we know, of course, that a fraction is also a division problem. All right, so A, Miss Almquist has 17 quizzes and each containing 7 questions. Well, I wouldn't need that to be a division. I would have no reason to represent that as a fraction. So Miss Bhattacharjee has 7 quizzes, each containing 17 questions. Again, this isn't a situation where I'm going to need to divide anything. C, Mr. Shand has $17 and spends $7 on lunch. That sounds like a subtraction issue to me. And D, Mr. Smith has $17 and spends it equally on 7 lunches. Well, he's spending it equally on 7 lunches. This is a pretty obvious one, right? Where I have my 17 divided by 7. Okay, guys. Next page. In 1990, a baseball card was worth D dollars. 1 year later, in 1991, the value of the card had decreased by 8%. Which expression represents the value of the card in 1991? All right, cool. In 1990, a baseball card was worth D dollars. 1 year later, in 1991, the value of the card had decreased by 8%. One down. Which expression represents the value of the card in 1991? So we're looking for the value after the decrease. Okay, so in my key information box here, I have my OPN chart. All right, and I know that the original value is D. I know that I took off 8%, and so my new value is basically D minus 8% of D. Okay, so D minus 0.08 D, right? Or it would be 92% of D. Okay, so I have 1.08 D. This would show if it was an increase. All right, so I have 0.08 plus D. That doesn't help me at all, right? I'm just adding 0.8. That wouldn't even represent a percent there. I have 0.92. 0.92 of what? And then I have 0.8D. So this would be 80%. Okay, and then I have 0.08 plus D. That's also definitely not going to work. This would represent an increase. And then, of course, C, it should be 0.92 times D. So we have a typo. Typo. All right, and so the actual answer is going to be, it would be 92% of, right, 0.92 times D, or it would be D minus D times 0.08, basically what I did over here. All right, so that's typo. I think probably they wanted C to have a D after that 0.92. It didn't. Let me look at this again. 1.08, yep, that's an increase. 0.08 plus D, that's would, I guess, also kind of be an increase. 0.92 times D, that would make it correct. And then 0.8 times D, that's 80% of D. Okay. All right. There was a typo there. Number 15 was a typo. I hope you guys haven't been driving yourselves crazy over that. Number 16, Jeremiah earns $3,900 per month plus 8% commission for each motorcycle he sells at a dealership. This month, he wants to earn at least $6,000. Write and solve an inequality to determine the minimum amount of sales Jeremiah must make to meet his goal. So we have sort of a combination of our percentage and our making two-step inequalities. So let's go back and very carefully read. So he earns $3,900 per month plus an 8% commission for each motorcycle he sells at a dealership. This month, he wants to earn at least $6,000. Write and solve an inequality to determine the minimum amount of sales Jeremiah must make to meet his goal. Okay, cool. So I'm going to do, sorry about that. I'm going to do key information box here. Key information box. So we want to make at least $6,000. Okay. We already have $3,900 per month that he makes. And we know that there's an 8% commission on sales. Okay. So what he wants to do is he wants to do 3,900 plus, okay, 0.08 times S, we're going to call that. That's our 8% commission times S for the sales is going to be greater than or equal to 6,000. All right. So I'll subtract that 3,900. Okay. And when I do 6,000 minus 3,900, I get 2,100. Let me make sure I'm right about that. 6,000 minus 3,900. Yep, is equal to 2,100. Okay, so I have 2,100 or 2,100. 0.08 S for sales is greater than or equal to 2,100. So let's see what that S needs to be. 0.08 divided by 0.08. So I'm going to go 2,100 divided by 0.08, and that's going to give me 26,250 Okay, so we need to make, or Jeremiah needs to make $26,250 $26,250 in sales. Okay, let me talk through that again. Okay, so we have $3,900 a month. That's his base pay. And then we have that 8% commission for each motorcycle he sells. This month, he wants to earn at least $6,000. Write in solvent inequality to determine the minimum amount of sales Jeremiah must make to meet his goals. Okay, so I had that 3,900 base pay. I added 0.08s, so that's going to be 8% of sales, right? And that would get me hopefully greater than or equal to $6,000. Subtracted 3,900 from both sides, and then I'm left with 0.08s is greater than or equal to 2,100. And I divide both sides just using regular order of operations by 0.08. My answer was $26,250. So that's how much money that Jeremiah has to sort of sell. Sorry, so that's how much the motorcycles that he sells has to be worth, $26,250 for him to get that 8%. Okay, we're going to move on. I'm going to erase some of this so that I have room to do my next problem here. Maybe. Here we go. All right. It takes Micaiah 40 seconds to run 1/3 of a lap. How many laps can she run in 5 minutes? Okay, so I have 40 seconds to do 1/3 of a lap. How many laps can she run in 5 minutes? My key information box here. I have 40 seconds to do 1/3 of a lap. And then we want to know how much is in 5 minutes. Well, there's a couple ways I can look at this. The first thing I could do is I could say, okay, if it takes 40 seconds to run 1/3 of a lap, and I'm assuming that she's going at a constant rate, although almost nobody runs at a constant rate for 5 minutes straight. But let's just say, for the sake of this problem, that Micaiah does. Okay, so if it takes 40 seconds to do 1/3 of a lap, so then to get an entire lap, it's going to be 40 times 3. So 1 lap, okay, is equal to 40 times 3, which is going to be equal to 120. Okay, so 1 lap is 120 seconds. Okay, so if I have 1 lap over 120 seconds is equal to X laps in 5 minutes. Oh boy, I have to do some converting now too. So this is 120 seconds. This is 2 minutes. All right, so let me change that. How can I erase it? Sorry, this is running a little slow. In 2 minutes. All right, so I can cross multiply. Okie dokie. So 1 times 5 is 5, and then 2 times 1 is 2. Yep, 1 times 5 is 5, 2 times 1 is 2. Okay, I had to pause for a second, guys, because I was looking at my work and realizing that I had written it just a little bit too sloppy. So I'm going to backtrack a little bit here, all right? Because I had written my proportion so sloppy that I couldn't read it, and I was saying 2 times 1 instead of x. All right, so going back to the beginning, we have 40 seconds for 1/3 of a lap. which means that we have an entire lap in 120 seconds, okay? And we want to know how far she can run in 5 minutes. So first I'm going to change that 120 seconds into minutes because there are 60 seconds in a minute. That means she can run 1 lap in 2 minutes. So I have 1 lap in 2 minutes. And this is where I confused myself. I wrote this x a little too sloppy, right? Is equal to x over 5 minutes. Okay, so I'm left with 2x is equal to 5. I divide both sides by 2. Okay, I am left with x is equal to 5 over 2, okay, which is equal to 2 and 1/2. Okay, does that make sense? If she can run 1 lap in 2 minutes, then she can run 2.5 laps in 5 minutes. All right, so she can run 2.5 laps in 5 minutes. And my apologies for that, guys. Let's keep moving down. Okay, solve and graph. Good old-fashioned solve and graph. Let's see. See if this really is good old-fashioned for us. Okay, so I have my inequality here. And already I can tell you that there wants to be a trick. Well, let's see if we can be tricked or not. All right, so I'm going to subtract 5 from both sides. Okay, get rid of the 5 here. Minus 5, I'm left with 8w is less than or equal to negative 11 minus 5, and that is going to be negative 16. Okay, 8w is less than or equal to negative 16 because I have a negative 11. I take 5 more away. Divide both sides by 8. I divide both sides by 8. I'm left with w is less than or equal to negative 16 divided by 8. Oops. Which is negative 2. Okay. Now, the trick here was, are we going to make a mistake and say that negative 11 minus 5 is equal to negative 6? Or are we going to get to this place where we're dividing by the 8 and switch the inequality? We do not switch the inequality because the coefficient to the variable is not negative, okay? So I'm left with w is less than or equal to negative 2. So here I'll put my 0, and I have to go down this way. So I have negative 1, negative 2, negative 3, negative 4. My w is less than or equal to, I'll do it in a different color. So less than or equal to means that this circle is closed because it could equal, and my point is going this way. All right, moving right along. A bottle of salsa has an original pre-tax price of $25, but is on sale for $20. By what percent has the price of the bottle of salsa been marked down? Okay, bottle of salsa has an original pre-tax price of $25, but is on sale for $20. By what percent has the price of the bottle of salsa been marked down? All right, OPN. Zip, zip, zip. All right, so my original here was $25. I don't know my percent, and my new was $20. So original times percent equals new. So we'll say 25 times P, because I don't know what that is equal to 20. And if I divide both sides by 25, all right, I'm going to go 20 divided by 25, and I'm going to get 0.8. So I'm getting P is equal to, okay, I have 0.8, which means that I paid 80%. So that means the discount was 20%. By what percent? So the discount was 20%, okay? Because 25 times 80% is equal to 20. And so 0.8, and 25 times 0.8, that's how I would do 80% is equal to 20. So I'm left that the 20% was the discount. That's what we took off. Okay, I am going to pause this video here. I'm going to make the next video right away, but this video is getting a little long. So I'm going to post it. And then if you're looking for page 5 and 6, that's going to come up in just a little bit.